Hello students, welcome to my Abhyas. My name is Sana KS and I am your physics educator. So in the last session we have discussed about the chapter which is called as motion in a straight line, right? So what does the motion in a straight line mean? Straight line in the sense which is going in a one coordinate system, you can say, or else the body is moving in only one direction, right? Now in this session we'll start with a new chapter, and that chapter is of class 11, that is motion in a plane. So what do you mean by motion in a plane then? So whenever we took the motion in a straight line, so what did we think is whenever a body was moving in a straight line like this, okay, and so it was only going in a direction, okay, only one direction it was taking. That is, for example, you can just take the x direction, right? But when you take motion in a plane, then what happens? So when you take motion in a plane, so when you throw a ball, first thing, the x coordinate is also varying because the ball is moving, and the y coordinate is also varying, right? So for example, if I am here and if I am throwing the ball like this, so for if I am throwing the ball like this, if this is the y coordinate and this is the x coordinate, then the ball is going in this manner, right? If the ball is going in this manner, then the ball is moving accordingly, that it is varying accordingly to x direction also, and also accordingly to the y direction, right? So from these two examples, you can just get to know the exact difference between motion in a straight line and motion in a plane, right? So now in this session we'll start with a motion in a plane and a very important concept which is called as scalars and vectors. Okay, so moving on. First thing, motion in a plane, we'll just define what is motion in a plane, and then we'll look into the concept of scalars and vectors. Okay, so coming to this first introduction, what does or how do you define motion in a plane? So when a body has motion in a straight line, there are only two directions possible. So either the positive direction or either the negative direction. So to describe motion of an object in two different directions or in three dimensions, okay, it may be in two directions or it may be in three dimensions, vectors are used to describe these physical quantities. So whenever you considered straight line, you didn't have any issue because it was only related to one coordinate or only related to one path, okay. But whenever a motion in a plane is involved, that is whenever the object is moving, when it is getting involved between the two coordinates or three coordinates, then what happens? Vectors come to the existence, okay. So for example, what I can write is, when I take x and y direction, so when I take x and y direction, and if I am throwing a ball from here, okay, so if the ball is here, just take the ball as here, and then you can just see it's varying with x coordinate also and it's varying with y coordinate also. So in the sense, what is happening? Two types of directions are involved, right? Two directions are involved, or you can say two coordinates are involved. So such type of motion, we call it as motion in a plane. Clear? So then we have an airplane also which is moving in space, and there you have x, y and z direction because it will be moving with the height, certain height, and it is moving through x direction also, and also it is moving through the z direction also, because space is a, like you can say, it's a huge plane, right? So all the coordinates will be involved in that. Understood? So that we call it as motion in a plane. Now we are only concerned about motion in a plane when two coordinates are involved. Clear? That is x and y, you can say, or x and z. So if we have to study motion in a plane or whenever a body is moving in a plane, then the vectors are involved because the vectors come to existence. So what are these scalars and vectors? Why did they invent this? First thing, whenever we consider scalars, because we have studied this, right? In the last chapter, we have studied distance and displacement. So distance was a scalar, displacement is a vector. So there you couldn't get it more, but here I'll be just elaborating the concept of vectors and making you understand it. Okay. So moving on, what is a scalar or a vector? So whenever, for example, if a body is moving, just check that it is, okay, so just think it is moving at 5 meters per second. So if it is moving at 5 meters per second, then what can you say here? We don't know in which direction it is going, whether it is going in the north direction, whether it is going in the south or in the east or in the west. Okay, but we know the body is moving at 5 meters per second. So this type of terms, we take it as scalars. Then what are scalars actually? So scalars are the quantities where only the magnitude will be involved. Okay, only the magnitude will be considered or magnitude will be taken. Okay, so the direction where, like if it is going to the north or whether it is going in the positive direction or negative direction, we are not concerned. We are only concerned about the magnitude, that how much speed it is going with. Okay, moving on to the next, scalars. So what are these scalars then? Now what I will do is, I'll just write 5 meters per second to the north. So you can see here, whenever I take 5 meters per second to the north, then what is happening? We have a vector quantity coming to the existence. Why? Because I am mentioning you the magnitude, which is 5 meters per second, and also the direction that it is moving. The body is moving towards the north direction. Okay, so here you can just say scalar is nothing but it shows only the magnitude, or it gives, or it is a quantity where only magnitude is involved, and vector is nothing but it is the quantity where both the magnitude and direction are considered. Okay, best example for this is, whenever you take a scalar quantity, it is nothing but the distance or speed, and whenever you take a vector quantity, it is nothing but it is the displacement and velocity. Okay, so we'll just go with the definition once. Scalars and vectors. So a scalar quantity is a physical quantity having magnitude and no specified direction. So the direction is not like involved or taken. Okay, whenever a scalar quantity is considered. So example for that is mass, length, temperature and energy. Okay, moving on to the next. A vector quantity is a physical quantity having both magnitude and a specified direction. So it has both the magnitude and specified direction, and the example for this is displacement, velocity, acceleration, etc. Okay, I hope the definition have been clear to you. Scalar in the sense only magnitude, vector is magnitude and direction. So we look into some of the differences between scalars and vectors, so that we will be deeply involved with those and we can easily divide which are scalars and which are vectors. Okay, so coming to the next. So first I'll just go with the scalar and vector difference, and later on we'll just see the representation of vector. So coming to the scalar, the quantities which have only magnitude and no direction are scalar quantities, which we know now. Then second one is, a scalar quantity is a one-dimensional measurement of a quantity. So a scalar quantity is a one-dimensional in the sense, you can just assume that this scalar quantity, okay, is a one-dimensional measurement of a quantity. Only in one direction you can measure it, right? Because you cannot measure it in more number of dimensions, because if you measure it in more number of dimensions, what happens? The vector quantities come to the existence. Okay. Next, a scalar quantity can be completely defined by a number and unit. So for example, I just write 5 meters per second. So if I write 5 meters per second, then the quantity is with the number and also the unit. Then you have a vector should not be thought of more like arrows pointing in a specific direction. So this is, I think by mistake it has come here, we'll just neglect it. Next, scalars obey mathematical rules for the operations such as addition and multiplication. So scalars, you have to remember, they go with the usual multiplication, division, then addition and subtraction, because whatever mathematical operations are there, the scalars are considered. The scalars will be taking that. That is 5 plus 5, 10. Okay, and then you have 5 into 1, 5. So these are all what? The scalar multiplication you can see. Then scalar can divide another scalar. So scalar is divisible also. Example, mass, length, time, etc. are all the scalar quantities. So these are the differences between difference or the characteristics of scalars also. And if they ask you a question based on give the difference between scalar and vector, you can give this. Okay, so generally they ask you that question, but also for the characteristics also you can refer the same. Coming to the vectors now. So the quantities which have both magnitude and direction are called as what? Vector quantities. A vector has more than one number associated with it. So a vector, it has how many numbers? One number which is associated with it. Then to express a vector quantity completely, we must specify the direction along with the magnitude. So in the case of scalars, the direction was not to be specified, but here in the vector, it has to be specified with the direction, that is with the magnitude. A vector should be thought of more like arrows pointing in a specific direction. So this you will get to know once we talk about the representation of vector. Then vectors obey vector algebra. So these vectors, they have separate mathematics with dealing with them, and that we call it as what? Vector algebra. So we have vector addition, vector subtraction, vector multiplication and vector division. Okay, we will be studying those things also. Vectors cannot divide each other. So these cannot divide each other. This is clearly taken. Examples are velocity, displacement, acceleration, etc. are the vector quantities. So these are the main difference between a scalar and a vector. So moving on to the next, we'll just see how a vector is represented and how a scalar is represented. So whenever you take a scalar, so scalar doesn't have any particular scalar, it doesn't have any particular representation. So representation is not there. Is not available, you can say. Okay, but when you consider the representation of a vector, when you consider a vector quantity and when you consider the representation of that, then vector is always represented by an arrow. Okay, so this arrow is nothing but whatever the length, okay, whatever the length is there, so that is given by the magnitude. Okay, and the arrowhead is nothing but the direction. Okay, so this length is nothing but it gives the magnitude, you can say, and this denotes the direction. Clear? And there is another point. Wherever the arrowhead is there, we call it as head of the vector or head. Okay, and wherever we have the other end, we call it as tail. Okay, the tail of the vector. Clear? So here we have the magnitude and direction, and also the tail and head of a vector. So vector, for example, if A is a quantity, certain quantity, that is certain magnitude, then it is represented as this. So this becomes a vector, that is A vector. Okay, or else you can other way to say that the value is vector is, for example speed I will consider. So when I consider speed, speed is also represented by V. Okay, and when I consider velocity, velocity is also considered as V. But how should I know whether it is a scalar or a vector? So this will be taken as bold. Okay, so this V will be given in terms of bold, which denotes that velocity is a vector quantity. Understood? So velocity will be a vector. Usually in your NCERT textbooks, they have written this. If a letter is written in bold, then it denotes that it is a vector quantity. Okay, then that is a physical quantity which is written in bold. Okay, you can just be normalizing that. And the representation of vectors we just saw, so that is represented by nothing but arrow. Okay, the head denotes the direction, the tail denotes, or the length of that arrow denotes the magnitude. Okay, and also the arrow head is, we call it as head here, and then this is called as tail. So very important theory to remember.